This is the intro video for Calculus BC, and we're going to be looking at Taylor polynomials and the approximations that come from that. And if you remember the very first day that we looked at series, when I tried to fool you with sine of x and how we built that, that series for sine out. This is going to be the more formal pattern for how we find these Taylor polynomials, and then we're also going to talk a little bit about something called Maclaurin polynomials as well. So here is how you do it. It's actually a pretty straightforward pattern as to how we construct these Taylor and Maclaurin polynomials. So this is for the nth Taylor polynomial for f at x equals c. So we're going to say that c is the centering point. And if we think back to that Taylor polynomial that we found earlier this year, our centering point was 0. The truth is the centering point can be just about anything we want it to be. So if you notice, the way this works is that our polynomial, our nth Taylor polynomial, starts off with simply f of c. So that would be the value of the function at our centering point. So it's actually pretty straightforward. You just take c, you plug it into the function, and that's your first term of the series. And then we add to that f prime of c times x minus c. So this would be, of course, the slope of f at our centering point, and then we multiply by x minus c. And you'll see this pattern built out here, f double prime of c over 2 factorial times x minus c squared. It's kind of nice to see with one of these Taylor constructions how the double prime, the 2, and the squared are all a 2. And then, of course, if you look at your fourth term in this case, well, the third derivative, 3 factorial, and third power, again, they all match up. So we'll find that these series can be manipulated, and some things can be changed in this regard, but a basic Taylor construction looks like this. And then the Maclaurin polynomial is actually just an adaptation or just a variation on the Taylor polynomial. As you can see, each of the terms really honestly look the same, except that in every case c is 0. So you can say that a Maclaurin polynomial is a Taylor polynomial at x equals 0. So your centering point is 0. You could call it a Maclaurin polynomial, but it really is just a Taylor at 0. Okay, so I hope you can see the similarities, the differences here. They really are the same type of construction. It's all kind of based on what we did that first day when we looked at series. Okay, so then just one reminder here that this stands for the nth derivative of f. It doesn't mean the exponent is 5 or 6 or 7 or whatever. It's just standing for the nth derivative. So this is talking right here about the 5th derivative. Okay, so we're going to take a look at a couple of these here. So if you would, take a look at number 1. So this says find the first 4 non-zero terms of the Maclaurin polynomial. So that means centered at 0 for g of x is equal to natural log of x plus 1. Okay, so I'm going to put here p of x, standing for polynomial approximation in terms of x. And here we go. So my very first term is going to be g of 0. So you can write stuff off to the side if you want. I'll just come down here. I'm sure a lot of these you can just do in your head. But g of 0 is going to be ln of 1, which is just 0. So technically that first term is a 0. Kind of a sticking point here because it says the first 4 non-zero terms. So we did some good work there, but that was not a non-zero term, and so we got to keep going. So I'm going to put 0 plus. Now I've got to find my next term, which will probably end up being my first term. So to do this, I need to find g prime of 0. So g prime of x is 1 over x plus 1. Therefore, g prime of 0 is equal to 1. Okay, well that's good, so that's non-zero. So it's going to be 0 plus 1x. technically over 1 factorial, but I don't think I'm going to write that. plus, moving on here, of course, this is x plus 1 to the negative 1, and I think that'll help us here as we get to our next derivatives. So I need to find g double prime for my next derivative. This will be negative quantity x plus 1 to the negative 2. And that, of course, means g double prime of 0 is equal to negative 0 plus 1 is 1, negative 2 is 1, so it'll just be negative 1. Okay, so that's going to be negative 1 times x squared over 2 factorial. So I got my first two terms. Now I'm going to work on hopefully my third term. So I need g triple prime. So g triple prime would be positive 2 times x plus 1 to the negative 3. So that means that g triple prime of 0 would be 2. So this is going to be plus 2 x cubed over 3 factorial. And then I'm going to come back up here and squeeze in my fourth derivative. So my fourth derivative of x is going to be negative 6 times x plus 1 to the negative 4th. Therefore, the fourth derivative of g at 0 will be negative 6. So this is going to be plus negative 6 times x to the 4th over 4 factorial. Of course, this is not simplified. We could clean this up a bit. I'll just come down here. I'll write this in a different color, so maybe it'll jump out a little bit. This would be p of x then equals x minus x squared over 2 factorial plus, I'll just write it as 2x cubed over 3 factorial. And that would be minus 6x to the 4th over 4 factorial. Clearly there are some cancelings I could do with the factorials and the 2 and the 6, but I'm just going to leave that alone for the moment. Okay, so I hope that makes sense. I would encourage you maybe with number 2 to pause the video and try it on your own. It's a very similar, we're gonna do a little bit more with it in the end, but it's a very similar question to number 1. All right, for number 2, we see that we're asked to find the 6th degree Maclaurin, of course that means c equals 0, polynomial for f of x equals cosine of x. And then, like I said, we'll do something with it. Okay, so first thing I need to do here is find my first term. So my first term is going to be f of 0. I'll just erase some of this as I go along, but I'm going to find f of 0 first. And f of 0 would be cosine of 0, and cosine of 0 is 1. So my first term, my first non-zero term is 1. Okay. So then I need to find my next term. So f prime of x is going to equal negative sine of x. Therefore, f prime of 0 equals 0. So my next term is going to be plus 0 x to the first over 1 factorial. So that's just going to be 0. Okay, so I'm looking for 6th degree. So far I've gotten up to 1st degree. To find the next one, of course, I need to find my second derivative. So f double prime of x is equal to negative cosine of x. Therefore, f double prime of 0 will equal negative 1. So this is going to be minus 1x squared over 2 factorial. All right, third term, based on f triple prime. This, of course, f triple prime is going to be equal to positive sine of x. Therefore, f triple prime of 0 is just going to be 0. So we're back to this. It would be 0x cubed over 3 factorial. You're starting to see this pattern. I hope that maybe you tried this one already and you were already starting to see the pattern. If not, hopefully it's clicking for you right now. Okay, fourth derivative of f at x is equal to cosine of x. Therefore, my fourth derivative evaluated at 0 is equal to 1. So this is going to be plus 1 x to the fourth over 4 factorial. And then my fifth derivative. So my fifth derivative, I think we're going to start recycling here, and we're back to negative sine of x. Therefore, the fifth derivative of f at 0 will equal 0. So this is going to be plus 0x to the fifth over 5 factorial. That'll just end up being 0. And then lastly, of course, my sixth derivative. I'll come down here. Sixth derivative of f at x is equal to negative cosine of x. So my sixth derivative at 0 will be negative 1. This is going to be minus 1 x to the sixth over 6 factorial. I was asked to find the sixth degree, and I can see now that I am at my sixth degree. So I'd clean this up and get hopefully a good final representation here. So we're going to say p of x is equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth over 6 factorial. That would be my sixth degree Taylor polynomial for cosine of x. Okay, so then we're also asked to use this to approximate the value of cosine of 1. So maybe that could look something like this. Let's say cosine of 0.1. So it would be cosine of 0.1 is approximately equal to p of 0.1. And then all we'd need to do here is use our Taylor polynomial to figure out what that is. So p of 0.1 equals, all I need to do here is plug in that 0.1, use the calculator, and approximately 0.995. And then just for sake of argument, if I wanted to know what that actually was, according to the calculator, cosine of 0.1 is approximately, look at that. Wow, it actually matches up perfectly. I'm seeing on my calculator, I'm sure you can see it too, all the way out there to the far end of the expression. It actually matches perfectly. So anyhow, just an example of what you could do with a Maclaurin or a Taylor polynomial. Hope that went well for you. We'll do some more practicing with these when you get to class. I'll see you then.